Okay, so welcome everybody. This is the lecture series of the System and Cybernetics Society, the Italy section. And as you know, the System and Cybernetics is a society of the Institute of Electronic and Electrical Engineering, IEEE. And in particular, System and Cybernetic has three aspects: the systems, the human, and the cybernetics control and modeling. And it consider all the paper related to the three aspects of human-centered research in these aspects. So I will ask you, if you are not a member of IEEE SMC, to enroll also to this society. This year, the main conference will be in Malaysia in October. Then we are sponsoring various conferences, the Human-Machine System, the conference on cognitive and computational aspects. We are organizing an SMC Italy Day in Bari for during the conference case 2024. The deadline is still on, so if you want, you can submit a paper for this special session on safe and secure human-machine interaction. Another conference on critical information infrastructure, and we are also organizing the conference on research and technologies for society in this industry that will be in Milan in September. And this is the list of the lecture series of this year. And today we have Professor Tanelli from Polytechnic of Milan. She will present a paper on diversity-aware design of sustainable mobility solutions, a control-oriented approach. She's full professor of automatic control at the DAIB department. She's very active on vehicle dynamics, in smart mobility, inclusive mobility. She has a lot of interest, and in particular, she is the director delegate for diversity and inclusion of the Polytechnic of Milan. Okay, if you want to start, Mara, please go on.
Yes, I share the presentation. Can you see it full screen?
Yes.
Okay, so thanks, Laura, for having me for this series of seminars. More than a paper, I will actually present in a broader sense this research on diversity-aware design of sustainable mobility. This research, I started this project, and now it's becoming a research group a few years ago, actually trying to bridge my expertise in vehicles and mobility and my, let's say, civic engagement in diversity and inclusion, which, as you said, I also pursue here at Politecnico di Milano. So this research is the result of trying to establish this bridge. Of course, I'm not working alone. There are several colleagues from the control community and also from the humanities. Viola Schiaffonati is a philosopher of science, and also among our PhD students, Camilla is doing her PhD here in Politecnico di Milano, but she graduated in philosophy. So we are a multidisciplinary team. It will be clear during the presentation why we need such expertise to carry out this research. So the context and the motivation is that, of course, mobility has a role within the current climate emergency. So mobility and greening mobility is a huge means for reaching the decarbonization goals. But for, let's say, the success of sustainable mobility in the decarbonization framework, of course, we need to change human behaviors massively in order for a massive amount of people to adopt sustainable behaviors, in particular in mobility, but you understand that this can be framed in a broader sense with much more different technologies that relate to sustainability. Of course, proposing a purely technical advance in mobility solutions, in vehicles, infrastructures, or whatever, is not enough to reach the sustainability goals. And so we think, and we are trying to offer quantitative tools and approaches to design sustainable and inclusive mobility solutions that can account for the individual diversity that is determined by socioeconomic factors and not only by mobility habits or let's say the technical aspects of mobility systems. So to do this, we are working along three different pillars. The first pillar is to model and quantify the attitude that persons have towards innovative mobility solutions. Because of course, the choice of, I'm sorry, I hear an echo. Maybe there's someone with an open mic. Thanks. I was saying that the first issue is to understand how persons relate with technology. In this case, mobility solutions, but as I was saying before, consider this as a broader approach. And of course, we want to offer tools that are engineering tools, quantitative tools. So in order to bring these diversity issues, these socioeconomic issues at the same level with the other technical aspects that we are used to measure, quantify, and analyze in our research activity. So we want to have a data-driven approach to understand the drivers of adoption of a new technology. Then, of course, each individual acts and behaves according to the social networks in which he or she is immersed. And so we want to study these adoption dynamics through network analysis. So we use the opinion dynamics framework and we define a network models with agents interacting among each other and sharing, let's say, information and opinions that can alter their intention to adopt the technology. On this network system, we also frame policy design to support the adoption of the behaviors that we want to foster. Finally, of course, people who decide to adopt arrive to use vehicles and services. And so in this case, we have a direct relation between the single individual and the service or the vehicle. So we can, again, optimize the direct relation between the two in order that this adoption is maintained over time. So how have we framed the work of these along these pillars? So to model the attitude towards the adoption of different solutions, we use input data, most often surveys, and we extract the socioeconomic factors describing the user's attitude towards the technology of interest. We do this with machine learning algorithms that I will be showcasing in a moment. Then we study the adoption using the network analysis. So we will characterize our individuals in terms of the drivers they consider for adoption, and then we put these individuals into networks where connections stand for the way in which and the motivation by means of which we influence each other along certain directions. And on these networks, we study the evolution of the adoption, both in open loop and introducing policies to foster adoption. You can imagine that, and you know that for sustainability issues, governments design policies to foster these behaviors. And so we want to have a tool to model these policies and also to understand how fairness can be enforced in the design of these policies. So the output of this pillar is a way in which we can frame, customize the fair policies to foster the adoption of the technologies. And then in the final layer, we want to tune and accord vehicles and services and policy settings to improve the user experience by means of monitoring this experience and enacting possible feedback loops on it. So this is the overall framework. I will delve more in the first two pillars, but just give a flavor of the third at the end of the presentation. So the analysis of adoption. We have named the output of this type of analysis the mobility DNA. So basically, we want to use the input data in order to get a compact indicator that uses quantitative information and outlines which are the main drivers of the individual attitudes towards technologies. In this example that I will make, we are talking about vehicle sharing services. But of course, we have used the same, let's say, approach for analyzing different sustainable mobility technologies. And of course, we want to account for socioeconomic factors and not only using mobility habits and technical considerations in drafting this DNA. Which are the input data? In this case, we have used Eurostat data, so surveys that have been carried out across the whole Europe. We have been using Italian surveys by ISTAT and different data that are available publicly in different countries. And we want to analyze the data, extract the features that matter the most with respect to a target question that we find in the dataset itself. And then, as I was mentioning, embedding this information in our mobility DNA, so this compact indicator that we will be able to build. So what are we using this DNA for? So first of all, we are using it to see whether we can cluster our population and understanding which types of set of individuals are more sharing-oriented or less sharing-oriented within our populations, and then design human-centered, possibly country-based policies, and also to check whether the policies that are actually have been put forward by governments in these countries are appropriate and how they can be improved. So this data had quite a lot of respondents. Of course, it was carried out with all the statistical accuracy by Eurostat, 28 European countries, and 39 questions that were about personal information and mobility habits. Of course, we have data that is both numerical and categorical. Our target question in the survey was this. So would you subscribe to car sharing if it was available? So we used this information as a target question, transforming it into a yes and no binary answer. And so we want to use the socioeconomic attributes and the responses to all the other questions but the target one to make a classifier that correctly maps this information onto the response to the target questions. Of course, technically speaking, when dealing with surveys, you need to do a lot of technical preprocessing, so data reduction, data cleaning for removing information that are not informative, possibly group attitudes to reduce the variance of the answers, and of course encode categorical variables into continuous one in order to have a complete data set that is consistent in terms of quantifications of the different features. In the end, we managed to clean our target question, and the survey resulted in these percentages of potential subscriber and non-subscribers to our potential car sharing. And this is an example on how we grouped the age variable in order to make some classes of different ages and transform the original continuous age value into classes. So, as I was saying, all the answers, or nearly all the answers to all the questions but the target ones, are considered as potential features that were used to learn classifiers that was correctly able to map these responses to the responses to the target question. So to define whether the current user was inclined or non-inclined to use sharing services if they were available. And so we used, in this example, gradient boosting, but you can use, of course, different types of classifiers that can be more or less performing in different situations. And so we managed to, let's say, get sufficiently neat learning of our target question. So, of course, we are interested in understanding which are the main drivers that guide this inclination to adopt our services. And in this case, at the end, the features that were selected as the most important in this respect was the fact that individuals were considering buying an electric vehicle or an hybrid electric, the country they came from, their environmental awareness, their education, profession, age, and income level. So you see that socioeconomic variables actually are the most present in this inclination analysis. So you understand how, if one completely overlooks this diversity and this socioeconomic identity of individuals, then it's not really possible to understand their technical choices or choices that we are inclined as engineers to believe to pertain more to the technical level, while instead they are more societal and individual. Okay, so when we get these features, we can build this DNA, in this case, the sharing DNA, as a vector of likelihoods. So basically, you can see here the spider plots that are the final, let's say, visual output of the DNA constructions. And so you see that the plots shows the main features that are the one that I was mentioning before. And so you can see that a smaller area of this polygon points to negatively inclined individuals, where a positive area points to positively inclined individuals towards the adoption of this technology. Of course, you can also use the area itself as a means to cluster individuals. And you have a very visual and easily interpretable outcome of these classifications of individuals. You can also go beyond and compress the spider plot area into a single index, which is here called the sharing index, by computing the normalized average of the vector of likelihood of each, let's say, feature that was in the spider plot, so that you have a scalar variable. And you can see the sharing distribution, the distribution of this sharing index. And so we used this distribution to compare it with the distribution of the positive respondents in order to see that there was a good matching between our DNA modeling and let's say, distribution of the positively inclined population that was in our original dataset. As I was mentioning, once you have these DNA characterizations of each of your individuals, so you see that you can grasp the diversity of each of your individuals, even though they can be grouped into clusters. And so, for example, in this work that was presented in the Smart Cities conference last year, we identified different clusters focusing on different, you see here, the 4 EU areas into which we grouped our individuals. So, for example, we understood that in Southern Europe, there was a group of persons that were inclined towards sharing, who were essentially young, well-educated, and with high environmental sensitivity. While, for example, in Northern Europe, there was a cluster of persons that were not so inclined in adopting sharing mobility, and they were essentially retired, more than 50 years old, with low environmental sensitivity. And so you understand that having this map can also inform in a data-driven way policymakers as to which are the individual aspects that guide these choices and that could be exploited in designing policies that can really target different populations and also different aspects of their characteristics towards which they are more responsive. So now I have shown you how we, let's say, describe each individual. Now, as I was mentioning before, the second step is to study the adoption dynamics by connecting individuals that up to now are single individuals characterized by their mobility DNA within a social network. For this study, which was presented at the World Congress last year, we took a subset of the data that I presented before, and we, let's say, concentrated, for example, on the data of persons that were respondents coming from Milano. So as we get the survey data and we build the mobility DNA, this we have already seen how was carried out. We connect the users into a social networks that models the interaction and the exchange of opinions, and by means of opinions of relative influence among the different individuals. And then on this network, we will be able to frame human-centric policies that can foster the adoption. Again, we will be leveraging machine learning, we will be leveraging opinion dynamics tools, and finally, closed-loop strategies to model the policy enactment. So in this case, by, let's say, pinpointing the individuals in our larger EU data set that responded from Milan, we got 158 respondents in the Italian region, and we consider them as a sample population living in Milan. Of course, this is an assumption to show the procedure. We constructed, from these 158 respondents, we constructed by let's say, distribution preserving oversampling, a prototypical population by generating agents so that their DNA was inherited by the samples individuals that responded in these initial populations, making sure that the statistical properties of the sample populations are preserved. So now, of course, the individuals must be connected. So we must create social networks and decide how we model the arcs connecting one individual to each other. Of course, from a conceptual viewpoint, these connections should mimic the homophily principle, in the sense that, in general, similar individuals tend to be influenced by neighbors, and we tend to, let's say, give more credit in the exchange of opinions and in the influence that we get by this exchange to persons that we feel close to us. So this homophily principle. Of course, people can be close to us because we encounter them in our daily life. People can be close to us because we share the same social network. There are many kinds of homophily that you can model within this setting. In this case, we decided to, let's say, model homophily as being physically closed, so encountering each other in the daily life. And so by exploiting the information on the mobility habits of the agents that were in the data, we were able to define the area of action in the mobility that was visited by each agent. And so we decided to connect two agents if their areas of mobility intersect. So this should, in principle, model the fact that these agents can encounter each other in their daily life. Of course, this is essential for sharing because, of course, you would share a vehicle or a means of transportation with someone who, let's say, somehow intersects your motion habits. And so in this way, again, in a data-driven quantitative fashion, we managed to construct the connection in our network. So agents are connected if their action area, in the sense of the mobility area that they visit, daily overlap. Okay, so now we have a graph with all these agents that are connected. And we model the diffusion process within a so-called irreversible cascade model. Irreversible in the sense that we postulate that once an agent becomes an adopter of our technology, then this adoption is forever. Of course, this is an assumption. We are now trying to understand how we can make also the process irreversible, but this is a very widely used model in opinion dynamics. And so up to now, we are exploiting this, let's say, this stream of modeling. So each agent can be either an adopter or a non-adopter, and the evolution of the state of the adopters is, of course, guided by, let's say, the percentage of adopters in each neighborhood that should exceed the individual resistance that each agent has, which is somehow you can see it as the inverse of the predisposition that we were talking about using the DNA. So you can model the predisposition or the resistance. They are the complementary visual views of our coming out from our DNA, and this diffusion model says that you decide to adopt when you see a sufficiently amount of your neighbors who do it. Okay, if we want to put control, so if we want to influence the adoption by means of external inputs, which in principle are the resources that the policymaker puts into the policy themselves, you can, let's say, write the evolution of the resistance of each individuals, adding a term where the control enters. And this scaling factor, which we call the individual receptivity, of course, it's like the B matrix in our control theory. And in this work, we considered that the individual receptivity could be randomly chosen, could depend on the environmental sensitivity of the agents, or could depend on the mobility habits of the agents. All information that we have starting from our DNA construction. Consider that in general, policies are flat as they are designed by governments. So once the government decides to support, for example, the use of sharing services, for example, they could do price policies, so lower the cost. But this is a flat policy that does not consider the individual by themselves. And so in general, these policies don't function very well, also because they are unaware of the specific populations to which they are directed. So here you see a classical cost functions of LQ control, where we, by means of which we want to find the optimal distribution of the resources such that this cost function is minimized. So the cost function in this sense can be seen with a Q term that reduces the resistance to the target value. And of course, at the meantime, we would like to do this by minimizing policy costs. Of course, we work on a finite horizon, and so we also have the final cost. Just to show you how it feels to use this type of policy design, we simulated the evolution of the network, and we tried, of course, with the 3 different random, environmental, and mobility-based B matrix. So with this modeling of the individual receptivity, we tried to test 3 different policies. So a balanced policies, so cost has the same weight as performance. Fostering oriented policies, so I privilege the increase of adopters with respect to the cost, and the cost efficiency policy, which is the reverse. I prefer spending less, possibly renouncing to a larger adoption. In these results, you can see for the 3 different policy strategies, the difference in the total costs that the policy bears, and the difference in the percentage of adopters after 3 months. So you immediately see that when we privilege the adoption, so the orange bar, of course, we have a quite larger number of adopters. We reach the full population, but of course, at the price of having larger costs. If we dually go for cost efficiency, we, of course, pay the price of having a few numbers of adopters. And if we go for a balanced policy, so the blue bars, we get, of course, intermediate results. And we already see that, especially in the percentage of adopters, the 3 different receptivity models, so the way in which we model the action that the control has on the individuals, you see quite different behaviors between the three policies. So to summarize this analysis of the adoption dynamics through networks, we have put together a framework which is a control-oriented framework for the design of mobility policies. Again, we are talking about mobility, but as you can see, you could transfer what we are doing in other technologies that have the same, let's say, link with the end users being any individuals in the population. And we have shown that actually with this tool, we can, at the design time, evaluate the potential that each policy has on our target population. So, of course, also this tool could be, in our view, quite interesting for policymakers because it could help to analyze, tune, and frame the policies at a higher level of understanding instead of going, as most governments do, with flat policies that act on every individual in the same manners. Starting from here, we also reflected that an important topic in decision-making is, of course, fairness. So apart from, as we were saying before, ensuring high diffusion of our technology and ensuring some sort of economicity of our policies, we should also bear in mind that policymaking should promote fairness in the sense of the absence of discriminations among different parts of the populations. And so what we try to do is to reason on 2 different fairness principles, equality and equity, which sometimes are, let's say, treated as synonyms, but they are not at all. So equality means that you provide everyone with the same amount of resources, disregarding the inherent differences in the individuals. So you don't give special treatments, but you don't look at diversity variables. While in the equity case, you provide everyone with the amount of resources needed to reach the target, so that, in some sense, each individual reaches a similar social position, potentially starting from very different initial conditions. What we're trying to do is to frame these concepts in a quantitative context. So we took the model predictive framework so that we could bound also the amount of resources that was not possible with the LQ approach before. And so we conceptualized what we call the FAIR model predictive control. We have the paper submitted to the TAC now on these issues. And so you see that we took the usual cost function and we tried to mathematically define equality and equity and to put them at the same, let's say, level of performance in the cost function, and showed that, of course, if you want to go for equality or for equity or for a combination of the two, the solutions that you get change a lot in terms of final cost, in terms of final performance. And so this is, let's say, a way of bringing these social principles on the table of the people that is really optimizing resources in a quantitative fashion. To do this of course, in practice, what we have done is to run of our network. I don't go into the details here, but I can point you to some initial papers that we have to integrate this FAIR MPC formulation in the context of mobility policies so that we somehow ensure or quantify how much our optimal policies can satisfy fairness criteria. And here is, in this conceptualization of fairness, is where the collaboration with our colleagues who are philosophers of science comes in, because they are helping us to frame from a philosophical and ethical perspective this concept of fairness, and we are trying to quantify and model what they are proposing as conceptual fairness definitions so that we can put them into our model and see how they influence the final outcome. In particular, we are considering what is called epistemic injustice, in the sense that we believe that the main form of discrimination in our system comes from the fact that the knowledge that different people have about a certain topic, consider, for example, mobility in this case, influences our different individuals depending on the credibility that each agent in the network has about the individuals being knowledgers. And of course, you can easily understand that, for example, age, gender, and race are social aspects that can undermine the credibility levels of individuals. So we are now modeling each agent in the network, not only according to its DNA, but also to its credibility levels. Modeling credibility both as a feature of each individual and a feature of the relations between individuals, because of course people who are in the same minority group tend to believe each other, even though as a group they are not believed by others. And so this of course opens up a challenging way of considering and modeling these aspects, which is now bringing us to formal tools to analyze such elements in our model. So of course we are seeing that social discriminations can hamper the action of fostering policies, and that it is important to be able of modeling this type of concepts in order to improve both the efficacy of the policies and their fairness on the whole population. To conclude, I just want to show you which is a possible example of work that one can do in the final pillar. The final pillar, as I was mentioning, aims to close the gap between this potential intent to adoption that we have put in place with our understanding of the population and with our policy making, potentially and hopefully fair policy making. But then individuals have to use concrete stuff. So have to take vehicles, have to enroll into services. And so in this case, the service and the vehicles will interact with the single individual. So for example, most probably, for example, Laura and I will come up to be very similar as far as our DNA and driving features are concerned, but in the end, I am Mara and she is Laura. So our interaction with the final physical vehicle or services will be different. And so we can exploit the degrees of freedom in the HMIs, in the optimization parameters, to really tune the final solution to each user. This is, of course, another very exciting research path that has many different directions that can be taken. This is simply an example in which we analyzed, for example, the driving style, taking into account different maneuvers taken by different persons. So the same maneuvers taken by different persons, the same person making different maneuvers, and understanding how each individuals actually behaved differently even when performing prescribed driving tasks. Of course, this information can be exploited in many different directions. So to tune assistant control systems to the specific driving style, to offer services that optimize the most common driving style for each person, and many more that you can think of in this type of context. So of course, there is a lot to do and a lot we are trying to do in all the three pillars. So we are using extended data sets. We want to extend what we have been doing for vehicles to micromobility vehicles, so e-scooters, bicycles, and so on. We want to work on the policy framework, understanding how to move from a centralized formulation, which we are using now, and is the one that I presented, to a distributed formulation that could model the fact that the EU governments set some goals that are then transferred to national governments and to local governments, or also go to, let's say, distributed in the sense of participative solutions for these policies that could go down to the single individuals, and exploit in this also some game theoretic perspectives. And of course, also for the user-vehicle interactions, try to play consistently with HMIs and with optimization parameters to see how different individuals lead to different instances of the same, let's say, underlying technical solutions. As the last thought, I wanted to share with you that starting last year, we have managed to make these concepts a topic of a course. So we started the master course, which is open. It's called a course of transversal skills, and it's open to the students of all engineering courses of studies here at Politecnico di Milano. It's called Diversity Aware Design of Technology Solutions, so a 5 ECTS course. And it's co-taught by myself and by a colleague who is a sociologist. And so we go through, of course, Chris first, my colleague, goes through the social definition of a community, of society, of the different variables that define diversity. And then I do the more technical part of course, the more going into more technical details than what I did today, but basically showing them these three pillars and making them reason about the fact that engineers should be aware of these aspects, social aspects in the design of technology, and can have really a central role to promote fairness and to work into these directions of making technologies more inclusive. Not only, of course, in mobility, but in many other sectors in which this aspect, I would say any sector in which this aspect is more and more central nowadays. Thank you very much. I now stop the connection so I can see you in the face. If you have any questions, I'd be more than happy to answer.
Thank you, Mara. Very interesting talk. So please, I ask the listener to make some questions, comments, curiosity. Don't be shy. Okay, before people maybe is thinking to some question, I have a question myself regarding your last slide. So what is the impact of this course? So how many students? So are the students really interested in taking this course?
It's an elective course, so they have to choose it and to put it into the program.
Yes, understood.
And this year is the second edition, so we have been having approximately 50 students in the course. They come from the most diverse engineering backgrounds, from management engineering, mathematical engineering, control engineering. So we had a very diverse class, and also many different nationalities. And we reason with them about the differences in the perception also of fairness and of that they have according to where they come from. And so I see, so large number that if you think that our master students are approximately, I would say in engineering, probably 5,000. So 5, it's like so it's like the 1%. But so those who come are super motivated and really like also the part in which we confront ourselves on these topics. So not only the technical part, but especially with Chris, it's more a philosophical way of doing courses. So we have many interactions. And it was very enriching also for me, who I am more used to, go to class, do your technical stuff. Of course, understand that, look at the students to be sure that they understand, but not discussing thoughts or perspectives also on social matters. So I think it's a very nice experience.
Yes, I agree. So any questions? Please go on.
You can also reach me afterwards if you have any interest.
I have another one regarding the predictive control, the fair predictive control. So you have three cost functions that you somehow merge each other with some weight, I think, weighting them. So how did you define the difference between equality and equity in the function? So is this coming from the discussion with the philosopher, as you said, or?
Yes, so the idea is that equality means that you give everybody the same amount of resources. So the cost function is an error between the amount of resources that you are giving to the single individual and its distance between the average amount of available resources, so that you make sure that you are not over giving to a single individual. While the equity is that you give resources to an individual based on the discrepancy between the distance that this user has between its state and the set point of the state. So how far they are from the target, which was. So
it's like one is more an H2 norm and the other is more an L1 norm, or no? It's just the definition of distance.
No, that's the definition of the error. That one basically looks at the fact that you are distributing resources in an equal way. The other one is that you are distributing resources according to how far the individual is from the target. So you admit that you may have an uneven distribution of resources because the point is to bring everybody closer to the target. And this is the equity part.
Oh, interesting, very interesting. I will read your paper when it will
hopefully
appear somewhere.
I hope.
Okay,
soon.
so...
But anyway, it was published on arXiv, so I can send you the link because we put it also on arXiv.
Okay. Graziana, Giancarlo, Elisa, questions? Just calling some names that I see. Or comments?
Yes, I have a short question. It's more a curiosity, let me say. You talk about the diversity-aware design of technology solution, and this is also the name of the course. So it's kind of really related to policymakers, if I understand correctly. Is it something that you think or you expect that can be adopted also in a private environment? I mean, big companies or any other kind of big person or element that can also think about diversity inside of a different perspective that is not public, let me say.
Yes, I have been discussing this with some persons from the corporate environment. And of course, my point is that they should be interested probably more to the first pillar, so to understand which are the drivers of adoption, so that they can, of course, maybe they don't do policy making, but they do advertising, so they have their ways into fostering the adoption of a certain technology that passes from channels that are different from the public ones. But should they be aware, for example, that the target population is very sensitive to environmental awareness, so they could promote and also shape the position of their company so that it appeals to this type of populations that indirectly, of course, becomes a more loyal customer. On the other hand, I do believe that, I hope at least that at some time policymakers will enforce some kind of level of fairness, or maybe with some other names, into some requirements also to industry, as they have been doing, for example, with green related KPIs. So my point is that if we manage to instill the reasoning that these social aspects are on the table of technical persons, or they are on the table of the persons that does the quantitative analysis, so they are not left there for someone else to come and evaluate in some other and different manner with respect to the things that we are used to quantify, then we can really initiate a dialogue, because of course, if I make policymakers frame their KPIs in a way that can be replicated to check that they are fulfilled, then of course you move the level of conceptualization of these green KPIs to a different level that is not something naive or shadowy, but it's something that really you can measure anytime in the same way. And so if you were 50 and now you are 40, it means that you have improved 20%. So of course it's
yeah, it's a complex topic, and of course it involves many actors, so it's not so immediate to implement it. But yeah, there's certainly interest and space to enlarge it and improve it. Thanks a lot.
Thank you. So there are no other comments or curiosity. I really thank Mara for her speech, very interesting, and it's important that we, as you are doing, that we create new engineers that are more sensitive to this equity and inclusion and diversity because they will be the future, and if they are sensitive, even if they are only 50, but 50 is a lot, because they will bring more and more where they will go for their work and so on. Okay, so thank you to everybody, and our next talk will be next month, end of April, and I will say goodbye to everybody. And as usual, the recording of this talk will be on our YouTube channel. Bye-bye, Mara.
Bye, bye.
Bye-bye.